Example number 5. Solve the differential equation dy over dx plus 8y is equals to exponential y, given that y is equals to 4 when x is equals to 0. So this one, automatically, it can clearly be seen that it is a linear first order ODE, isn't it? Yes. It is a linear first order ODE. So a linear first order ODE you cannot solve with method of separation of variables. You cannot solve it with the method of homogeneous first order ODE, isn't it? So you know very well that a linear first order ODE is in the form dy over dx plus by is equals to q, where both p and q are functions of x. Are we together? So from this your equation, you've been given dy over dx plus 8y is equals to exponential x. You can see there's no coefficient in both. So from here you can clearly see that p is equals to what? Because it is py plus py, meaning p is 8. And you can clearly see that q is exponential. So how do we solve a linear first order ODE? The first thing is to get r, isn't it? What was r? R was given by the exponential of integral of p dx. Can you recall that? Yes. When we were solving the linear first order ODE, r is the exponential of integral of p dx. So what is r? That is going to be the exponential integral. You put the value of p. P is 8, meaning it is 8 dx, isn't it? So we are integrating 8. If you integrate 8 with respect to x, what do you get? You get r is exponential. If you integrate this, what do you get? You get 8x plus, isn't it? You get 8x plus c. So I do prefer that when you are getting r, you leave alone the arbitrary constant, because plus c like this simply means plus exponential c, which means this exponential c you put to be a, so it is a8x. So there's no need of putting the constant, because when we are going to get that second equation, the constant this side will get also another constant when we are integrating the other side of the equation. Are you getting that? So when you are dealing with the value of r, just get r without the arbitrary integration constant. Are we together?
Yes.
You just get r. Is that okay? Yes. So we now have r is exponential 8x. If we integrate 8 dx, you factorize 8 outside. If you integrate dx, you remain with x. 8 times x is 8. So we found the value of r. After getting the value of r, we now go to our second equation, which was, remember we multiplied all through by r, isn't it? Meaning at the end there, we add qr, isn't it? Are we together? And this side, we were doing more. See, we were differentiating the ry with respect to x. See, those are the two equations you compare. Are we together? So you add the ddx of ry to be equals to qr. So start the substitution. dx of ry is equals to, what is q? What is r? Q is exponential x, and r is so it is q, which is exponential x, times r, which is exponential 8x. Are we together? Yes. So the x going on the other side of the equation will remain with the d of ry to be equals to, if you take dx the other side, you remain with exponential 9x dx. Lots of indices. Same base, you add the powers with multiplication sign. Let me see. So exponential times, that is same base, you add the powers. X plus 8x, you get exponential 9x. Then you've taken dx the other side, isn't it? Yes. Then what do? So you introduce integral. Are we together? Yes. So this integral goes with the d. What do you remain with? You remain with ry, because that one goes, isn't it? You remain with ry to be equals to, you are integrating an exponential function. When you integrate an exponential function, it remains the way it is, isn't it? Yes. It remains exponential 9x, then you divide by the derivative of the inner function, which must be a constant. You divide by that 9, isn't it? Then at the end it is plus the arbitrary integration constant. So are you seeing the reason why when we were getting r, we were not putting the constant?
Yes.
Because at the end of the integration process, we will still get the constant on the other side, isn't it?
Yeah.
Are we together?
Yes.
Now, this constant, is it supposed to be there C or exponential C? It is supposed to be exponential of that constant. Why? Because you want to substitute the value of R, meaning this C, everything, when you leave it there, just C, we are going to substitute back you C, okay? Put the value of R, what was R? Because we've completed the integration, there is no longer integral anywhere, meaning we are done, we've solved it, isn't it?
Yeah.
Are we together? When you no longer have any integral anywhere, it means you solve the differential equation. So what is left is to substitute, meaning this R is to be substituted, isn't it? What is R? Meaning you have exponential 8x times y to be exponential 9x over 9. So you can see this is exponential, meaning the other one is also exponential. Are we together?
No.
We are not together. Okay, if we are not together, just leave it as C. Nobody will penalize you for that. Just leave it as C like that. So after you left it as C, what do? We want Y. See, we divide all through by exponential 8x. Are we together? For us to get Y, we divide all through by
Exponential 8x.
Exponential 8x. Just leave it as C. By the way, it is good to leave it as C because here we have a product of exponential and Y. Not everything is exponential there, isn't it? Are we now getting us? Where's the... Yes, we are together. So if you divide both sides by exponential 8x, you get exponential 8xy is equals to exponential 9x over 9 plus c. We now want to divide all through by exponential 8x, exponential 8x, exponential 8x. What do you get? This cancels with that, you remain with y. Exponential 9x, remember this is 1 over 9, isn't it? 1 over 9 exponential 9x over exponential 8x, you remain with loss of VDC, same base with the division sign, isn't it? Because this is 1 over 9, you factorize that, you remain with exponential 9x over exponential, same base, you subtract the powers with the division sign, isn't it? So you remain with 9x minus 8x is Are we together? Then it is plus c exponential negative. Remember 1 over, when something is in the denominator, see that means negative. Yes. When you have 1 over x, that is negative 1. When you have 1 over 2, Are we together?
The exponential. The one we learned together that we have brought.
Which one? See here, you see times that?
Yes, we left it there. Now it has come back.
What we are doing is just this. We are simply dividing this everything here with exponential 8x.
Yes, that is.
So that we have y is equals to 1 over 9. Exponential 9x over exponential 8x is exponential x. Then here you have c, 1 over exponential 8x is exponential negative 8x.
Yes. I was saying, there you told us to leave the constant. We leave the exponential part of it, and then after some.
No, you are reasoning well. You are reasoning well. Even if you let this one to be exponential, it was going to be exponential c, so that same base you add the powers, isn't it? Yeah. But I'm saying you just leave it as a constant c because here we had a product of y and r. Y is not having an exponential function. So we just leave it as c. We say you only let it, if it is ln of c, all the terms must be ln, isn't it? If it is exponential c, all the terms must be exponential, but y was not exponential, so you just leave it as c. It is understood, isn't it? Good, very good. Now after this, we now want to get rid of c, isn't it? For you to get rid of c, you say y is 4 when x is 0. Meaning where there is x, you put 0. Where there is y, you put 4. So what do we get? 4 is equals to 1 over 9 plus c, isn't it? Because this is exponential 0, anything raised to 0 is 1. You remain with 1 over 9, isn't it? This is exponential negative x times 0. Negative 8 times 0 is 0, isn't it? exponential is 1, you remain with c. Are we together? So what is the value of c? 4 minus 1 over 9, isn't it? Which you get to be 4 minus 1 over 9? 35 over 35 over 9. So what is the solution of your differential equation here? The solution of the differential equation is y is equals to 1 over 9 exponential x plus 35 over 9 exponential negative x. Where there is c, you put the value of c. Then you finally solve the first order linear ordinary differential equation. Very simple, isn't it? Very clear.